Student, this is your mathematics class for class 9th. This is your chapter 1, chapter name number system, and this is your lecture 4. In this lecture, we will start with your exercise 1.4. In 1.4, we will learn how we will represent real numbers on a number line. In my first lecture, I taught you that every real number has a unique position and representation on a number line. We know it very well to represent any rational number on a number line, but the question is how we will draw non-terminating terms or non-repeating terms with repeating terms on a number line. Now, we will learn with the help of some examples. First of all, we will take an example 2.657. Now we will learn how we will draw this number on a number line. Definitely we know it very well that this number lie between 2 and 3, because on a number line we have numbers like 0, 1, 2, 3, 4 and -1. We know it very well that this number is lie between this area, between 2 and 3. So we will enhance this part. We will enhance this part like this. So between 2 and 3, we know it very well. We have 10 subdivisions or portions. They are equal to each other. So I marked it. It is 2 and it is 3, then 2.1, 2.2, 2.3, 2.4, 5, 6, 7, 2.8, 2.9. Now some of the students are thinking what is the difference between these two numbers? This is 2.0 and this is 2.10, means 10. When we will complete one round, then we will add to the left side of the decimal, then it become 3. Now we know it very well that this number is lie between 2.6 and 2.7. So we will enhance this part of the question. With the help of magnification, we will enhance or magnify this part between 2.6 and 2.7. So 2.6, after it 2.61, 2.62, 63, 64, 65, 66, 67, 2.68 and 2.69. Now the number is 2.657. Definitely 65 is complete and then 7, then it means it is lie between 2.65 or 2.66. 2.65 and 2.66. We will magnify this part, and then again 2.66 and 2.6. So 2.65 and 2.66 divide into the 10 equal parts, like 2.651, 2.652, 2.653, 4, 5, 6, 7, 8, 9, and then at the end 2.66. Now this is our required number which we want. It is 2.657, our required number. Now the question is, this is a normal decimal expansion. If we have a non-terminating but repeating term, then how we will draw the number on a number line? So if we have a question like this, it means 4-6 bar means it is non-terminating but repeating, and this portion is repeating again and again and again in this question, that is mean by the bar. So we will take 2 digits which are repeating under the bar, and then we will draw that number. It means we will magnify this part one more times, and then we will get our answer. So students, now we learned about the process of successive magnification. Now I will switch on next topic, which is operation on real numbers. Now you know it very well that the real number means the collection of all rational and irrational numbers. Collection of all rational and irrational numbers. If we are talking about rational numbers, it means fraction, then we know it very well then how to add them, how to subtract them, how to multiply and divide them. Now we will learn how we will proceed all these operations with irrational numbers. So first operation is addition. In this addition, we will take one question about addition. So add these two numbers or these two algebraic expressions which are present the combination with the combination of rational plus irrational numbers with mathematical operations also. So we will write like this: add them, first bracket, add second bracket. Now in real numbers with irrational number, one rule is this: then root 2 is not able to add in root 3 because they are two different irrational numbers. So we will search same irrational numbers, root 2, root 2. Here we have plus 2 root 2 plus root 2. Take an example: if we have one mango and another person have 2 mangoes, then the total mangoes is 3 mangoes. So like this, 2 root 2 and 1 root 2, it become plus 3 root 2 plus 5 root 3 minus 3 root 3. Here we have 5 times root 3, here we have 3 times root 3, but we have with different sign. So when we multiply these operations plus minus, then it become minus. So we will subtract them. 5 root 3 minus 3 root 3, 2 root 3, and the sign is only about the bigger digit. So which one is bigger? 5 is bigger or 3 is bigger? Definitely 5 is bigger. So we will take positive sign. If we will have here more than 5 any number, then we will take minus here. This is your addition. Now next thing is subtraction. In subtraction, again we will subtract two algebraic expressions in which some irrational numbers are also present. So subtract this from this. So first of all we will take first bracket and then subtract and second bracket. So the question is why I put that bracket here, because in our previous question in the addition I never put that bracket, because reason is when we have a minus sign in between two algebraic expression, then we have to put this bracket for our ease, because if we don't put this bracket then we are not able to change their sign properly, and sometimes students always forget to change sign. So for this we will put these bracket. Now root 2 minus 3 root 3 minus then open this bracket, and when we open this bracket, because negative sign is present, then the sign under the bracket will be changed. So plus minus minus plus minus minus, then it become minus 2 root 2 minus 5 root 3. So same irrational number root 2. Here we have positive 1 root 2, here we have negative 2 root 2. So plus minus minus, when 1 is subtracted from 2, then it become 1 root 2, and sign for bigger digit. And here we have root 3, both are same sign, negative negative. So minus minus plus, so 5 plus 3, here we have 8 root 3, and sign is according to bigger digit. So this is our answer. So these two types is based on addition and subtraction. Now we will switch on multiplication. In multiplication, same as if we will take an algebraic expression, and when we will multiply these two numbers, we have one rule only. First of all we have to multiply sign, then we have to multiply number, and then at the last we will multiply roots. So in these two terms, first we will multiply sign, plus into plus plus, then number, 6 2s are 12, then root 5 into root 5, root 5 into root 5, then 6 2s are 12, root 5 into root 5, 5. Now some of the students are thinking how it is possible, because in 8th class you already know about laws of exponent. When we have a power m and the same base with the different power and the multiplication is there, then the powers will be add. Similarly here we have 5 power 1 by 2 into 5 power 1 by 2, because we know it very well, then the value of this sign is root, then it become half plus half 1. And in the next part we will take two algebraic expression, 5 plus root 7, 2 minus root 5. In your last chapter polynomial, I already taught you how we will multiply when these two types of bracket is present. First of all, we will take first term from the first bracket and then multiply the second bracket. Then we will take second term with sign and then multiply second bracket. 5 into 2, 10 minus 5 root 5, 5 root 5 plus 2 into root 7 plus minus root 7 into root 5 is root 35. All terms are different, so they never be add or never be subtract. Now one more example, if we have a question like this, root 3 plus root 7 whole square. In previous chapter polynomial, I already taught you identity a plus b whole square, which is equal to a square plus b square plus 2ab. In this question, we only replace a with root 3 and b with root 7, and then we will get our answer. And in another example, root 11 minus root 7 multiply with root 11 plus root 7. In these two algebraic expression, if you noted that a and b, the placing value of the terms are same, but only sign is different. So we know our identity a minus b, a plus b from your previous chapter, which is equal to a square minus b square. So we will only put or replace value of a is root 7 and value of b is value of a is root 11 and value of b is root 7, and then solve it. And now some of the students, if they did not saw the lectures of polynomial, root 11 square, how it become root 11 only, because square means a number multiply by itself. Root 11 into root 11 is 11. Now these are all operations which we will follow on real number in this exercise. Now next topic of this exercise, representing root n. N means a natural number on a number line. It means now we are going to learn how we will draw a natural numbers or square root of a natural number on a number line. So I took an example, root 5.7. If we want to draw root 5.7, for this, first of all we will take a number line 5.7 AB, which is equal to 5.7 with the help of scale. Then we will make one more unit which make this AB add one unit, which is AC is equal to now 6.7. This is our rule, and we will take one more unit of the given number. Now we will first of all we will draw a perpendicular bisector on it. How we will draw a perpendicular bisector on it? We will open this compass more than half and put it here and draw this semicircle. After this, I will draw a perpendicular on 5.7 point, it means at point B, and then it cut the semicircle at point M. Now this line should be equal to root 5.7. Now I will prove how it become root 5.7. We will join center with this point M. Now in this triangle we want to find this height MB. So this is complete 6.7. So half of 6.7 is 3.35. This is our radius. So definitely it is also equal to 3.35 because it is also radius. It touch the center and the circumference of the circle. This is also radius, which is equal to 3.35, and this is 1 unit. So minus, after subtracting this 1 unit from 3.35, it become 2.25. Now I will apply Pythagoras theorem, because we already know that I draw perpendicular here. In MOB triangle, hypotenuse square is equal to perpendicular square plus base square, which is equal to MO square plus is equal to MB square plus OB square. we will put these values and start solving it. Then it become MB is equals to root 5.7. It shows with the help of Pythagoras theorem we can apply with the help of Pythagoras theorem we can prove it. It is root 5.7. Now we know it very well. Now this point is root 5.7, but we want to show this root 5.7 on a number line. Then how we will draw? Then we will take B as a center. We know it very well. Then this is our root 5.7. So we will take B as a center and put our pencil on M and then draw a arc like this. So now by this method we will draw root 5.7 on a number line. Now students, it's all about your homework. So this is your homework today. You have to do questions of exercise 1.4 and 1.4 complete and 1.5 question 1 to 4. Now solution of your previous lecture. This is the solution of your previous lecture, lecture number 3. So in lecture number 3 we discuss about your exercise 1.3. So question number 7 is write question number 6 is look at the several example of rational number in the form of P upon Q, where PQ are the integers with no common factor other than 1 having the terminating decimal representation. Can you guess which property Q must be satisfied? It means in this question we have to prove that if we will take some examples related to terminating decimal, then we want to show the property of Q which must satisfy all the examples. So let us take some examples, which is like 5 upon 2, 2 upon 5, 2 upon 10 and 5 upon 16. They all are terminating terms. If you have any doubt, then see it. Answer of this is 2.5, then 0.4, 0.2 and 0.3125. Now you can see it easily that Q must be satisfied in the form of either 2 power m or 5 power n. It means individual. It may be 2 power something and then 5 power something, or both 2 power multiply m power in P upon Q form. If you are not understanding, then please see. Here we have 2 power 1. Here we have 5 power 1. Here we have 5 into 2. 5 power 1 and 2 power 1 also. Here we have 2 power 4. So it shows that Q must be satisfied either it is 2 power something or 5 power something or present both. So next question number 8 is find 3 different irrational numbers between 2 rational numbers. This is your question number 8. We have to find irrational number between these 2 rational numbers. So definitely first of all we have to change these rational number into the irrational number. For their decimal expansion we have to divide 5 with 7. After this we will get this, and then 9 upon 11. Then it shows like this. They are also, because they are rational numbers, and this is their decimal expansion. So we should write infinitely many irrational number between these two, because we know that it is 0.7 and it is 0.8. So we will take our examples greater than 0.7 and less than 0.8. It never be less than 0.7 and greater than 0.8. So like one example 0.73074059 dash dash dash, and second example 0.79420075 dash dash dash. You can take any another example, because so many different examples and infinitely many irrational numbers are present in between these 2 rational numbers. Hope you get this concept, irrational number and rational numbers, and then study with your NCERT and do practice. Thank you.